Today we are going to look at another subtopic under surds, which is rationalization of surds. Rationalization of surds, and the objective that we will be accomplishing today is rationalize at least two surds with monomial denominator. That is, the denominator is having only one term, and rationalize at least two surds with binomial denominator, meaning that the denominator will be having what? Two terms, that's binomial. So what then is rationalization? It is the process of converting irrational denominator into a rational. It is the process of converting a fractional surd with irrational denominator into a rational. For example, 1/√a. It is having what? Irrational denominator. So we are supposed to convert this into rational. How do we do it? We multiply both the numerator and the denominator by √a to make it rational, and this is what we call rationalization. So here we are going to get √a over √a squared. The 2 will take this away for us to get √a over a. 1/√2. We multiply the numerator by √2 and denominator by √2. So this will give us √2. √2 times √2 is what? 2. That is √2 squared. So that this will take this away, leaving 2, which is √2 over 2. So this is what the monomial type. Look at another example. So this is 1. We look at another example, that's 2. Let's take 3/5. So how do we rationalize this? So this, what we will do is 3/5 times √5 on √5. So 3 times √5 will give us 3/5 all over. √5 times √5 will give us what? 5. That's √5 squared. So the 2 will cancel the root sign to give us what? 3/5 on 5 as our final answer. So let's continue with the binomial type. So that one, for example, 1. Let's say 1/3 plus √2. This is binomial because it has what? 2 terms. So how do we rationalize this? We learned earlier about conjugate of surds. So we have to first look for the conjugate of this, the denominator, and then multiply the numerator and the denominator by the conjugate. This is what I mean. We multiply here by 3 minus √2, which is the conjugate of this one, all over 3 minus √2. So from here, 1 multiplied by here will give you the same. So 3 minus √2 all over. This is difference of 2 squares. So you square the first one minus the square of √2. So this will give you 3 minus √2 all over. 3 square will give us 9 minus. Here the root sign will cancel this. So we get for 2. So minus 2. So finally it will be 3 minus √2 all over 7 for this one. 3 minus √2 all over 7. So let's take another example. Example 2, you look at, let's say 2 plus √3 all over √3 minus 1. We are going to rationalize this one. Look for the conjugate of the denominator, which is √3 plus 1, and multiply by the 2. So which will √2 plus √3 all over √3 minus 1 times √3 plus 1 all over √3 plus 1. So we multiply the numerator then the denominator as well. So 2 times √3 will give us 2√3. And 2 times 1 will give us 2. After that, then you multiply √3 by the whole of this. Plus √3 times √3 will give us what? √3 squared. Plus 1 times √3 will give us the same. That's √3 all over. √3, this is a difference of 2 squares. So we have √3 squared minus 1 squared. So from here, you will have 2 √3 plus, we have 2 here, this will cancel, so we are going to get 3 here plus 3 plus root 3. All over these two, this will cancel to give us 3 here. So 3 minus 1. So here we have one numbers that we can put together. So 2 plus 3 will give us 5. And 2 plus 1 root 3 will give us plus 2 plus 1 here root 3 all over 2. We are going to get 5 plus 3 root 3 all over 2, which can be further written as 5 on 2 plus 3 on 2 root 3. So here, from here, we go to this part. So 5 plus 3 root 3 all on 2 will give us what? 5 on 2 plus 3 on 2 root 3 as our final answer for rationalizing this one. So let's try this on our own time. Try out, simplify. So on your own time, you can try this one. So we've learned about how to rationalize sets with monomial denominators and those with binomial denominators. Yes. This brings us to the end of our lesson, and what I'll say is that practice makes us perfect. So continue to practice, because the more you practice, the more it becomes very easy for you. Math is not difficult. If and only you practice, you become perfect. Thank you.